Hi, this is Lori, and this is my homework or walkthrough for the Cogsworth City Kit by Inventor.io. This is for day 7, and this shows the wiring diagram for day 7. We'll have 3 LEDs and then 3 buttons. These 3 buttons will be used to turn the LEDs on or off. It'll be a momentary turn on and off, not a toggle. And we'll also include our photoresistor to adjust, when these are on, we'll adjust the light level of the LED, the brightness level of the LED based on how much light there is. So it'll be brighter when it's less light and less bright when there's more light. That's the intent of the exercise. So we'll start there. I have a couple of modifications that I'll show. So this might be one of the longer videos since I'll go through replacing the photoresistor with a potentiometer as a way to kind of tweak the brightness to whatever we want. I think it's a little easier to see the changes than trying to use a photoresistor to do that. It's just only so much you can change the light level with this. But I did try some modifications to kind of make it more dramatic, so I'll start off with that. All right, so we'll first start off with the code pretty much as shown in our lesson. Here's our code. It's pretty much the same as what's shown in the lesson. The only thing that I did differently was I already fixed the LEDs are all plugged into pins that use pulse width modulation. One of the, I think, goals of the lesson was to kind of teach us, what the PWM pins, the pulse width modulation pins, they have to have that tilde next to them when you look at them on the board. That tells you that that's a pulse width modulation pin that can do that. And if you have something plugged into that and you try to use pulse width modulation, it works okay, but it won't obviously use different brightness levels. It's only going to have a high or low for brightness. So it's all fully on or fully off. All right, so the code's pretty similar here. We need the variables to track the buttons, and this is going to be where we just, the light will be on as long as we're pressing, and it comes off as soon as we let go. And so that's the variables we need to track that. Then the light level, and then what brightness level we're going to give to the LED when we do have the button pressed. And in the void setup, we'll set those up as outputs that we have been doing. And since I do have it set up with the external pull-down resistor, then we'll do our pin modes that way. Now you'll notice I have some comments in here to say, we could use a different way of doing the resistors, the pull-up, and use the internal resistors that are in our hero board, and we just activate them by giving it some of the code to tell it to put one of those in place for us. And this is the kind of code we would use to do that. We say input underscore pull-up to say a pull-up resistor. But with a pull-up resistor, now we're pulling up the pin that the button's connected to high when it's not pressed. So when we press the button, it will read a low, and when it's not pressed, we'll read a high. And that's the opposite of the pulled down resistor. So we have to keep that in mind. And I think that's one reason why the lesson used this, is because it's maybe a little more intuitive to say it'll be high when it's pressed and low when it's not pressed. But so with the pull-up, we'll have to flip that around, and I'll show that in the alternate version of this code where I set this up and show you how it's different and how we set up the buttons to use that internal pull-up resistor. We'll set up our serial monitor, and then the loop will read the buttons, we'll read our light level, and then we'll use this map function that I think for the first time in these lessons. And the map function just takes one scale of numbers and relates it to another scale in a linear fashion. So we take our actual light level, which is on a 0 to 123 scale, and we say take that value and now scale it into a 0 to 255 scale linearly. So that's what the map function does. And yeah, it's pretty straightforward. And if you look up that in the Arduino code manual online, you can see the function that does that. It's probably something you did in algebra in high school. Anyways, so let's just take the green LED. If the button is high, then we're going to turn the LED on, and we're going to give it the brightness level that we determined from this map function. So we use an analog right now rather than a digital right to turn on the LED and give it a specific brightness level. And then otherwise, if the button isn't pressed, then we're going to turn it off and we'll turn the brightness to 0. And we do that for the blue and the red. And I'm going to print the light level and the brightness level to the serial monitor so we can see what's happening, and we have a short delay. So it's pretty straightforward. So let's turn on the serial monitor here, and we can let it get settled here. We can see the light level in the room and the brightness. So if the light level were up to the max of 1023, then the brightness would also be maxed to 255. So we're a little bit below the max, and we're a little bit below the max for brightness. So that seems to be working pretty well. So let's just check our red light. It comes on. And then our blue light. It's not super responsive because we have that delay in there. It seems to be working. So let's go back to red. And now let's change the brightness level. And you can see in the printout in the serial monitor, we definitely changed the light level. And the brightness level going to the LED changes. But it's kind of hard to see. It's a little easier to see on the side when you look at the side of it rather than straight on. But yeah, the code's working correctly. And I'm not covering it quite good enough. There we go. And then, yeah, you can kind of see it. Not sure it films real well, actually. You can see it a little bit in person. And like I said, I think you can see it a little bit on the side. But I find that kind of a little disappointing. So in my alternate version, I decided to make that more dramatic. So I took a little bit different approach to adjusting the brightness using the photoresistor. And we'll also show you how to do the internal pull-up resistors in my alternate code too. So that's next. All right, here's the alternate version for day 7. So first off, we'll just take a look and see how the buttons are now set up a little bit differently. So now they're connected to ground on one side, and the resistor is gone, because we're going to get that from inside the Arduino or the Hero board. And now on the other side of the button, we just connect it to the pin. And that's going to connect it into the 5 volts. So yeah, that's how we do a pull-up resistor. So it's a little simpler. We don't have to have the 10K ohm resistors. They're going to come from the Hero board themselves. So a little simpler setup, I think, there. Yeah, so let's just take a look at it. So all the setup of the buttons and the LED is the same, and we'll still need the same variables. And now I'm going to try to make the change in brightness when we put our finger over the resistor a little more dramatic. So as we were doing the previous time, I kind of took a look at what was the max light level I was reading and what was the min when I put my finger over it. And I noticed it was around these numbers. It may vary as the day goes on, so we'll make sure it works. But I just changed those to what I was seeing when was nothing on the resistor, and what number was I getting when I put my finger over it. And then I decided to divide the range up into 3 levels of brightness. So we'll take the max minus the min, divide it by 3, and we'll call that light level third. And so then we'll have only 3 levels of brightness rather than sort of infinite that we had with the way the code was done before. So I think it's just kind of hard to see the impact of it when you're demoing it. Yeah, so here is reading the buttons, And then here we're going to look and see what level of brightness we want to give. So instead of using that map function, I'm doing this. So if the light level is in the min to the first third, so the kind of the first third of the range, then we're going to give a pretty low brightness of only 5. And if it's at the max, kind of in the max third of the range, then we're going to give it a full brightness. And otherwise we're going to have, well, I should say a medium level of 50. And you notice that I didn't evenly divide it because I told you about that nonlinear. So 5, 50, and 255. I think you can kind of see those with your eyes. And yeah, so that's how we set up the brightness. So I guess that's a little more complicated, but I was just trying to have fun to see see brightness changes. And then we just, the code remains the same after that. So I did make it a little more complex because all of this if, else, if, if, else code replaces that simple map function before. But I was just trying to create more visible change in the brightness. All right. Well, I went back and saw that when I demoed this, it didn't quite, wasn't quite real successful. So let's, I'm going to kind of clip this piece in here, I guess. So we'll try pressing the red button to turn it on. And if we look down in the serial monitor, we can see that we're at 255. So now if I I block the light a little bit, I need to block it just a little bit more, we can see we got to 50. And if I block it all the way, I should get to the 5. And then 50 again. Yeah, there we go. And then no blockage of the light, and I get the full brightness. And it works for all the other colors too. So that might be a little bit better demo than the first one I did. So we've successfully demonstrated the kind of tiered approach I did for the brightness. But I think the best way to play around with brightness in an LED is to use a potentiometer. And I know we don't have one in the Cogsworth City Kit, so if you don't have one, you may want to just pass this part of the video by. But if you do happen to have one in your possession, it's a fun thing to play around with, using it to change the brightness of an LED. So let's first learn about what potentiometers are and a little bit about how they work, and then we'll put it into our circuit in place of our photoresistor. So a potentiometer is just, in a way, just like the photoresistor. It's a resistor that has a changing resistance, and instead of using light to change the resistance, we just use the dial to change the resistance. So that's why we kind of swap it in and out of a project like this and just have a different way of changing the brightness, because we'll respond to where we're turning this knob to rather than the light level in the room. And that's why, I mean, it gives you a little more control, and you can go from the fully off to fully on by using a potentiometer, and we don't have to worry about how much light we actually have. So yeah, they're just different ways of doing it. And just some more details here. The one I'm going to use is this one. It's often called a trim pot. Typical new beginner kits will have some of these in there. The other thing they might have in there is one that looks like this, and this is one that's used. It's called a panel, I think, typically panel potentiometer, because it can be mounted into a panel, and you know, they're used for things like volume control, that sort of thing. So yeah, so we'll use this one here. It's pretty straightforward, and we'll swap it in the place of our photoresistor. So let's see how that gets set up, and then give that a try. All right, we're here with the code for the potentiometer instead of the photoresistor. And the first thing I'm going to do is just show you what this looks like on the breadboard. So you can see here's this potentiometer, kind of small, and one side is connected to power and one side is connected to ground. You can actually flip that around and it'll just change the direction that the potentiometer works. And then the middle pin is the one that goes back to our analog pin. So that's how you set them up. So I'll slide over here and just show you what it looks like underneath here. So I'm going to looking back at my monitor here just to make sure. So you can see the 3 pins there. And so the middle one is the signal pin, and then a power and a ground. And like I said, you can flip them. And then this little knob will turn. It's a little hard to turn. Sometimes you'll see me try to turn it with my fingers here because it's just easiest to film the way I have it set. But a lot of times I take a screwdriver and turn them because they're kind of hard to get your fingers around. So that's this kind of trim pot version that you find sometimes in kits. The other version is the panel. So this is what a panel one looks like, and usually the signal pin is the middle, and then power and ground. And this one, sometimes there's little caps on them, you know, like you might see a dial on a piece of equipment. And so you just turn that knob to change them. A lot of times when you get them in a kit, the beginning kit, they come like this. They don't get the cap. It's kind of frustrating, I think. But anyways, that's what a panel one looks like. All right, so we've got our trim pot in there. So now, close my monitor here. Now we'll just talk quickly about the changes in the code. It's not as much as you might think. Here's I'm going to call it the pot pin instead of the photo pin. And I'll be reading in the loop pot value instead of LED or light level, I guess it was called before. And all the rest of it's set up the same. And now we'll just read the potentiometer, and we'll call it pot value. And then we'll need to, I'm going to do that map that we did in the original code for the lesson. So we're going to map pot value, which would be on a 0 to 1023 to a 0 to 255, and we'll call that LED brightness. And then all the rest of the code stays the same. So let's give this a go. All right, so I'll try the well, let's do the green one. So hopefully I keep my fingers out of the way. So I'm going to press and turn on the green one. And you see I'm pressing and nothing's happening. And that's because I have the potentiometer. Oh, I meant to turn on the serial monitor. So you see the potentiometer is 0 right now. So the LED brightness is 0. So even though I'm pressing the button for the green one, it's not coming on. So let me turn the potentiometer a little bit. And there we go. Now we can see the potentiometer value and the LED brightness. And I have this going a lot faster than it was before. I changed the delay. And I'm going to go ahead and turn it all the way up to its full brightness. And we'll turn it back down again so you can see it come down to off. And it works on any of the pins. Any of the LEDs, I should say. And yeah. So I find that fun. And I think another thing you could do is change this program to a toggle switch rather than and then it would be easier to kind of dial and watch the changes so that the LED stayed on, and you could kind of twist and turn and watch the changes. Well, that's just my little add to the lesson. Using the potentiometer, because I think that's a lot of fun when you're talking about brightness of an LED. Well, there we go. I've done all I can with day 7, and as always, I want to thank you for watching.